This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. NASA has awarded SpaceX a contract to build the Deorbit vehicle, or DV, that will be used to deorbit or remove the International Space Station from orbit. The International Space Station Deorbit vehicle will be a custom-built, one-of-a-kind spacecraft that will ensure that the space station re-enters the atmosphere at the precise place and in the proper orientation to ensure that it does not survive re-entry and that anything that does will harmlessly crash into the sea. Here is more from the group The Great SpaceX describing the changes SpaceX plans to make to the Cargo Dragon spacecraft create the deorbit vehicle, which will drive the space station out of orbit when the lab is retired in 2030.
Last month, NASA announced an $843 million contract with SpaceX to develop the ISS deorbit vehicle known as the United States Deorbit Vehicle, or USDV for short. But now, SpaceX has unveiled even more astonishing details than anticipated. Specifically, the USDV will be an extended version of Dragon. Surprisingly, the new design features a significantly longer trunk, which will accommodate additional thrusters. This extended trunk is expected to be twice as long as the current design and will hold up to 6 times more fuel. Meanwhile, the front section of the deorbit vehicle resembles a Dragon 2 cargo spacecraft. Sarah Walker, SpaceX's Director of Dragon Mission Management, confirmed the vehicle design will build upon SpaceX's Dragon cargo spacecraft with an enhanced trunk section that will host propellant tanks, engines, avionics, power generation, and thermal hardware tailored to complete this mission. And you might wonder how many thrusters will be used on this Super Dragon. Currently, Dragon employs 16 engines. However, with significant upgrades to the trunk and fuel capacity, the new Dragon, designed to deorbit the ISS, will boast up to 46 Draco thrusters. This means it will generate 3 times the thrust of the original version. With this power, it will guide the ISS back through Earth's atmosphere and ensure a controlled descent into the southern region of the Pacific Ocean. Currently, the ISS return process to Earth is expected to span 12 to 18 months before the final deorbit burn is executed. During this period, approximately 22 to 26 engines will be activated to propel the ISS, achieving a speed of 57 meters per second, or roughly 3,420 meters per minute, which is also equivalent to 205.2 kilometers per hour. Notably, NASA plans to let the station's orbit naturally decay for about 6 months after the final crew departs. The crew will leave once the station's orbit has decayed to around 330 kilometers, down from its current orbit of approximately 400 kilometers. Regarding the launch schedule, it's still uncertain which one SpaceX will use for the larger Super Dragon. Currently, Falcon 9 is the primary candidate due to its long-standing role as Dragon's main launch vehicle. However, with Super Dragon's increased size, SpaceX might opt for its larger sibling, Falcon Heavy, which shares similar systems.
Dana Weigel, the International Space Station Program Manager, details the deorbit procedure.
We do plan to continue fully operating the station through the end of its life. When we reach that eventual end of life, we will deorbit the space station through a controlled re-entry, and we will put it in some uninhabited part of the ocean. We haven't picked the exact location yet, but it will be in some very large uninhabited region. This controlled re-entry deorbit method is the same deorbit method that we use for other large spacecraft, like the Northrop Grumman Cygnus or JAXA's HTV cargo vehicle, so it's a very common operation that you would do to dispose of something very large. The deorbit itself is the responsibility of the entire ISS partnership. So that is shared across Roscosmos, the European Space Agency, JAXA, the Japanese Space Agency, and the Canadian Space Agency. The way the space station is designed, the Roscosmos segment has the propulsive capability both on board the segment and also through Roscosmos-provided cargo vehicles called Progresses. Early on in the station planning, we had considered doing the deorbit through the use of 3 Progress vehicles, but the Roscosmos segment was not designed to control 3 Progress vehicles at one time, so that presented a bit of a challenge. And also the capability wasn't quite what we really needed for the size of station. So we jointly agreed together to go have U.S. industry take a look at what we could do on our side for the deorbit. So we developed a concept of operations and a set of requirements for using a vehicle on the U.S. OS portion of station that would be docked to Node 2 forward. And then last fall, we released an RFP to U.S. industry to help us develop this U.S. deorbit vehicle. The vehicle's main purpose is to do the final series of burns that happen over about the last week of life of a station as it's reentering. As you know, we recently awarded that contract to SpaceX. One thing to keep in mind is with any new vehicle development, it can be pretty complex and sometimes it can take a bit longer than what you expect. Historically, vehicles of this level of complexity could take 5 to 8 years to develop, and so we thought it was really important that we start now. The contract itself is different than other station crew and cargo transportation contracts where we're using a service-based approach. The other contracts for transportation vehicles have end-to-end services for transportation, meaning they cover launch all the way through operations of the vehicle. This contract is a bit different. This vehicle itself is being delivered to NASA, and then NASA has the responsibility to go and procure a launch vehicle and also to operate it. We'll do that launch vehicle procurement in the future using NASA's Launch Services Program. The USDV has such a critical function for us. Obviously, it's got to continue to perform critical burns, even if it encounters anomalies. So we require high reliability and a two-fault tolerant approach to the vehicle design. So in the RFP, one of the things we asked for is maximizing the use of heritage flight-proven hardware so we could increase the reliability. Of course, there is no existing vehicle that meets the high propulsive needs of the USDV, but we certainly can leverage hardware and systems that have been flown and tested in space already. The SpaceX concept leverages the Dragon vehicle, but about half of the vehicle will be new design, new development, and 100% of the new deorbit functionality that we need is new to the spacecraft. Ideally, we'd have the U.S. deorbit vehicle delivered well in advance of the station's end to life, as Ken mentioned. So the contract has what we call a dwell-in storage requirement in it. This allows us to deliver the vehicle early and then just store it and do periodic maintenance on it until we're ready to launch it. When we do make the decision to deorbit the station, we'll launch the USDV about 1.5 years before the final reentry burn. We'll dock it to the Node 2 forward port. We will do a series of checkouts, and then once we're convinced that everything looks healthy and we're ready, we'll allow ISS to be lowered down and begin drifting down. It takes a while to drift down. We think that'll be about a year to a year and a half in total of drifting down. We'll leave the crew on board as long as possible so they're available to help maintain the station and keep it healthy. Our plan is for them to leave about 6 months before the final reentry. As ISS reaches about 220 kilometers, the USDV will perform a series of burns to set us up for that final deorbit, and then 4 days later, it will do the final reentry burn. While we're preparing to be ready for the eventual deorbit of ISS, we're also very focused on continuing to fully utilize the platform and maximize the use. There's still a lot of new and exciting things we're doing on board the vehicle. There's still quite a bit to accomplish. We're also mindful that if we were in a position where we needed to extend ISS a little bit to avoid a gap in low Earth orbit, we also want to be positioned to do that. We'd really like an overlap between station and the next platform. LEO is really an important place for us for a lot of the research and activities that we want to do, and it's very accessible, and it's a springboard and a jumping off point for what we need to test and learn for deeper space exploration missions. When the time does come to retire ISS, we'll plan to do an orderly transition from station to a commercial destination where we're hopeful that NASA will become one of many customers.
It saddens me to think of deorbiting the International Space Station after all these years of amazing service, but I guess that everything must eventually come to an end. Thank you for joining me, and thank you for listening from your home or where you work. And wherever you listen, be sure to like and follow us. Listen each Tuesday for This Week in Space with John Gomez. And join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends and follow us on Facebook. Join us each week for news and information on America in Space.